Welcome back from Thanksgiving break. We do not have that much more to do. We have one more test that would cover chapters 4 and the information that we do in chapter 9. So that's going to be a combination test. And then the final. And our final is on Wednesday, December 13th. And that will be during class. And as was told in your syllabus, you have to take the final or you'll fail the class. Yes, Joey.
Can we also get a review on My Math Lab?
That's right. There will be a review for the final on My Math Lab. That will also.
Like the last test, or like not? Yeah, it's not.
It's cumulative. It covers everything. It does.
So we won't have class after that?
That's right. After the 13th, we won't meet anymore.
How soon will we figure out our grade for the?
When you get done with the final, it would tell you right then what you made on the final. I will still go back in and give a quick look to see if I can see if there's like a negative missing or something, like you didn't simplify your answer, you know, and can give you partial credit for things like that. I can go in back and do that. So within a day, I mean, once you know that, boom, 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 in Blackboard it calculates it and you see what it is. The only difference would be is if maybe I went back and gave you partial credit. So you need to give me that night to be able to look back over everybody's stuff. So within a day. Any other questions? So everybody should be able to see their project scores. I graded those. I put those in. You can see them in My Math Lab and in Blackboard. We don't return the projects because we have to keep them as documentation. But if you have any questions about your particular one, I still have it, and I can go over anything that you have questions about. Okay, so if you're questioning what happened on a particular problem, I'll be glad to go over that with you. But we have to keep those for documentation that we did the labs. Last time, are there any other questions about anything before we get started? Okay, you need to make sure that you have the TI-84 calculator. So if it's not this exact one, you can have a newer model or a later edition. It just needs to be able to do matrices. And so I'm giving you a heads up with that. I assume most everybody has that. If you don't have one, you need to let me know. For those of you here on campus, I'll bring one in for you to use while we're in class. But you'll want to use this for Chapter 9. And you also can use it on the exam. So you'll want it for the exam too, for Chapter 9 questions that are on the exam. So be aware of that for your calculator. Last time we started 4.6, and this time we're going to finish. We had made it through all the way up to example 3. So example 3, and remember with the first few pages here, there's not enough room really for you to squish everything in. So you might want to write the answers on your own paper. This, you may have enough room here. It's getting close, but I'm going to put another sheet of paper here so we can see it. All right, so this is with example 3. We're doing exponential functions, and they're modeling population growth. It says, according to the U.S. Census Bureau, the world population reached 6 billion people during 1999 and was growing exponentially. By the end of 2010, the population had grown to 6.947 billion. The projected world population in billions of people, t years after 2010, is given by the function f of t equals 6.947 e to the 0.00745 t. And this is the question. Based on this model, what will the world population be in 2025? So when they're asking us for the world population, they're really asking us to find f of t. That's really what we're looking for. And f of t, remember, is just another way to say y. They're looking for what is y when I'm dealing with 2025. Now, Do I put 2025 in the place of t? No, I don't. This says that t is the number of years after 2010. So I need to figure out how long is 2025 after 2010. So all you have to do is to subtract 2010 from 2025, and you get 15. So they're saying find y when t is equal to 15. That's what we're doing. So if you want to use function notation, they're saying f of 15 is equal to 6.947 e to the 0.00745 times 15. So that's function notation right there. Okay, and often we just put a y there. But this is saying, hey, look, I'm going to this function and I'm plugging in 15. Now, you should be able to plug that into your calculator by now with practicing in your homework, and you'd get 7.768, but remember, they define this in billions. So we would expect to have 7.768 billion people at the end of 2025. So the key to that problem was paying attention to how they define t, and then I need to say what is t and use 15 for t. All right, then I'm just plugging it in. Now for part B, it says if this trend continues, approximately when will the world population reach 9 billion? So they're asking us to find t because they're saying approximately when. Find t when our y is equal to 9 billion, y being f of t. So this would set up as 9 equals 6.947 e to the 0.00745 t. So let's see if we can remember things we did from before Thanksgiving. What do we need to do to both sides first? Okay, one little step before that, but you're on the right track. That's right. So divide both sides by 6.947. And now we will take the natural log of both sides. And remember, they cancel each other out. So I have on the right-hand side and then I'll just divide both sides. And you need to practice this, making sure that you're putting it in your calculator correctly, because you could have all this work done right, but just typing it into your calculator incorrectly is going to give you the wrong answer. So practice that and see if you come up with 34.8 for t. So I'm going to give you just a second and see if you get 34.8. And let me know if anybody's having any trouble getting 34.8. The second thing to pay attention to is 34.8 is not our answer. I do want to find t when y was equal to 9, but we have to answer their question. And their question was, if this trend continues, approximately when will the world population be 9 billion? So remember, t is the time since 2010. So to answer their question, I have to say 2010 plus 34.8. So the answer is going to be sometime in the year 2044. So during the year 2044, the population will reach 9 billion.
So why wouldn't you round that up?
Because the whole 0.8 is just telling me that I'm still inside that year. If I rounded it up, I'd skip time. Yep. Now, if the instructions in my math lab told you that you could round, but otherwise,
Okay.
that's why we use the word during. Any other questions about example 3? All right. Now we can go to your next page. And this is where it says decay models. And the thing to be careful of here, or the vocabulary word that we want, is this blank is the amount of time it takes for a quantity that decays exponentially to become half of its initial value. Does anybody know what that's called? You've taken science? Yes, half-life. That's called your half-life. It's like, how long does it take for me to have half of what I started with? So again, I'm going to use fresh paper here because I don't think I can fit it on this page. This is example 4. All right. It says we want to suppose we have 600 grams of a radioactive substance, and that's initially. So I know my beginning amount. And then 3 years later, I only have 300 grams. Determine an exponential equation that models this decay. All right. Well, remember your basic exponential equation that we have from last time is y is equal to y sub naught times e to the kt. We were told y sub naught is your initial amount. So I know that my initial amount was 600. That would be my answer, except they did not tell me the value of k. And remember, if they don't tell you k, you have to find k. When we have an equation, we can only have one thing that we do not know. And I don't know k. So they need to tell me other information that's going to give me a relationship between y and t. So I go back and I say, oh, look, 3 years later, I have 300 grams. So there's a relationship between my y and my t. T is time, because notice this, when t equals 3, then that y equals 300, right? That's from right there. All right, so I can put those values in to find the k that I need. So I'll have 300 equals 600 e to the k times 3. So I'm going to solve this for k. So first I would divide each side by 600. That would reduce to 1/2. Natural log of each side. And then divide by 3. And just put that in your calculator. And negative means that I'm a decaying function, okay? And so therefore the function I need is y is equal to 600 e to the negative 0.231 t. See, this y sub naught is 600. That never changes. That's your initial amount. Any questions about part A there? So same thing, whether I'm growing or decaying. If they don't tell me K, I have to find it. The second question says how much of this substance will be present after 6 years. So how much of the substance is asking us to find Y when T is equal to 6. Find Y when T is equal to 6. So I just used my equation that I just wrote down. So let's write that down again. And then all I have to do is put a 6 in the place of T. And you should be able to put that right into your calculator. And always make sure that you're giving the right units. So Y is representing the amount, and our amounts in this problem were given in grams. So you should have gotten 150 grams. All right, any questions with example 4? All right, example 5. So you see why I gave you these handouts, because we wouldn't want to have to write all that information out. This is about carbon dating, and in Blackboard, if you go and look in Blackboard, I posted 2 little articles about carbon dating. Sometimes you'll hear about carbon dating in your science or in articles that you read, and it's interesting, everything that science uses all has error in it. And you need to be really careful about just assuming, just because somebody used a formula and number crunched it and they seemed really like smart, that everything they say is true. And there's 2 articles there. And the thing about carbon dating is they're comparing the amount of carbon, I think it's 12 and carbon 14, because we breathe in and when we're living, we're taking in carbon dioxide. And then when we die, we stop doing that. And so they're comparing the ratio of what is a known amount of proportion to what is a found amount of proportion. And that tells them how long it's been that I haven't been taking in carbon dioxide, right? It tells them that ratio. Well, the thing is, as long as they're dealing with organic things that we're living, then they can be fairly accurate. But if they start doing things with inorganic things, then they're not going to be accurate. And there's 2 articles there about lots of things, about how they date ages of things. And also, they've also determined that within a close amount of age, they can be fairly accurate with carbon dating. But once they start trying to be very far away, it gets a lot more error in there, because they don't always know what the actual ratio of carbon 12 to carbon 14 there was at that particular time. So it's just very interesting. They will use carbon dating to support things. Like if they use other methods to date items, they can use carbon 14 kind of as a buffer to say, look, we got the same thing. But they're not just only going to rely on carbon dating. But I bring that up because this is the example that they talk about here, is carbon dating. And it says carbon 14, also known as radiocarbon, is a radioactive form of carbon that's found in all living plants and animals. After a plant or animal dies, the radiocarbon disintegrates. Scientists can determine the age of the remains by comparing the amount of radiocarbon with the amount present in living plants and animals. This technique is called carbon dating. The amount of radiocarbon present after T years is given by this particular formula, where Y sub naught is the amount present in living plants and animals. They want us to find the half-life. Now notice they didn't tell us what Y sub naught was. They didn't tell us the initial amount. But remember, we've had another problem like this where they didn't tell us the initial amount, but it turns out okay because that value ends up being canceled out. And it's the same thing here. Remember what half-life is? I want to know, when do I have half of my initial amount? So I want to know, I want to find out how long does it take for y to equal 1/2 y sub naught, half of the original amount. So using the original formula that they gave us, in the place of y, I'm going to write 1/2 y sub naught. And then using our same pattern, if I divide each side by y sub naught, notice that my y sub naughts cancel out. And then I'm just going to go through the same process that I've done over and over again. We'll take the natural log of each side. And then just divide both sides by that long decimal. And I get approximately 5,700. So they're saying here that our half-life will be approximately, I'll put wiggle lines, approximately 5,700 years. So it would take approximately that long for this particular substance to have half of what it started with. So our process in all of these problems is the same. Hopefully you found the pattern to that. The thing that you need to be careful of is when you read the problem, make sure, am I looking for t or am I looking for y? Okay, that's the question. And then if you're dealing with t's, make sure that you're plugging in the right value for t. Okay. Part B in this same problem has charcoal from an ancient fire pit on Java contained 1/4 the carbon-14 of a living sample of the same size. Estimate the age of the charcoal. All right. So what we want to know here is that we're looking for t because they said estimate the age. So I'm looking for time, and it said I had 1/4. So estimate the time when our y is equal to 1/4 the original amount. So putting this into our formula, we would have 1/4 y sub naught equals y sub naught e to the negative 0.1231216. Okay, so remember this right here is our y, and I read the problem for them to tell me what my y was supposed to be equal to. Just as before, you divide both sides by y sub naught, and you have 1/4 equals. And then you would just take, same as before, natural log of each side. And then divide each side by that negative long number. And I'll just tell you, I get approximately 11,400. So they're saying that that piece of charcoal, in their estimation, would be 11,400 years if they use carbon dating. Okay. Any questions about example 4 or example 5? Okay, last example for our decay problems. This is Newton's law of cooling. And you do have enough room on this page to write everything. All right, so you have the same paper as me, and it says Newton's law of cooling says that the rate at which a body cools is proportional to the difference in the temperature between the body and the environment around it. The temperature f of t of the body at time t in appropriate units after being introduced into an environment having constant temperature t sub naught is f of t equals t sub naught plus c times e to the negative kt. C and k are constants. So this means if they don't tell me those two values, I have to find them. Okay, so remember before I only had a k. Now I have a c and a k that I'm going to have to find. They want me to consider a pot of coffee with a temperature of 100 degrees Celsius. It's set down in a room with a temperature of 20 degrees Celsius. So that's your environment. Okay? The coffee cools to 60 degrees Celsius after 1 hour. Write an equation to model the data. Basically, I'm using this relationship and I just plug in the information that I know. So right now, the information that I know is T sub naught is 20 because that's my environment. Okay. Now I need to find C and I need to find K. All right. Well, C is the one you're going to find first because I know what happens when time is 0. All right. When time is 0, that means I'm at the beginning of things. What is the temperature of my coffee at the beginning? Read back through here and see what's the beginning of my coffee? 100 degrees. So when T is 0 at the beginning of time, then my coffee, then F of 0 is equal to 100 degrees. So I can put 100 degrees here and put a 0 there. And see what happens when I do that? This entire exponent is going to go to 0, right? Because 0 times k is going to be 0. And anything to the 0 power is 1. So this whole piece right here would turn into the number 1, and that would allow me to have 100 is equal to 20 plus c. See that little strategy? Subtract 20, and I found out that c is equal to 80. So the first thing we had to do was find the value for c. Now the second thing we're going to have to do is now go back and find the value for k. Right, so second thing we need to do is find k. Right? So let's rewrite our little equation, putting in the information that I know now. So I put my c in that I just found. And my 20, which is still true, that's my environment. Now remember, if I want to find k, I need a relationship between t and y, right? That's the second piece of information that they give me right here. It's 60 degrees after 1 hour. So I'm supposed to be 60 degrees after 1 hour. Okay, so that's 80 e to the minus k times 1. So subtracting my 20 gives me a 40. Dividing by 80 gives me a 0.5 or a 1/2. And then I just go through the process of doing natural log. So my k is equal to negative 0.5. Once I found the c and I found the k, now I can write the equation that I need to use. So therefore, my equation will be my original amount plus my 80 e to the, now if you put that, I lost my natural log, didn't I? I lost my, nobody said, you lost your natural log. Okay, I lost my natural log. Okay, so if you put that in your calculator, negative natural log of 0.5, put that in your calculator and tell me what kind of answer you get. Do you get a positive answer or a negative answer? So when I took the natural log of 0.5, I get like negative 0.693141, and I take the opposite of that. So that is 0.69315, depending on how far you take it out. So this would be negative 0.693 t. Will be positive, right? Would it be negative? Let me put that in my calculator and make sure I get the same thing I'm telling you. That's right. Okay, so here's where we're going to be careful with how we're putting our notation here, all right? In our formula, this little piece says e to the minus kt. So I need to make sure that I'm putting in the value for minus k. So here, even though I'm solving for k, I need to be careful because I'm ultimately wanting to know what minus k is. And minus k is going to be that, what, when we do natural log? 0.5. That's going to give me my negative 0.69315. Okay, so the number that's actually going to go here is the minus value. Okay, so be careful just about your signs. And that's the formula that we want. Okay.
So that negative sign in the formula doesn't cancel that answer out?
Correct, because then that depends on where I'm looking. If I'm looking at this row, this says negative k. You see that? So that's taking the place of the whole negative k, and I'd put in.
It took care of it.
That's right.
Okay.
That's right. And then if I was looking here and looking at just the k and wrote that there, then I would need to put the minus in front. So it depends on where I stopped in the line. Good. Very good. All right, so that answers part A. So now that we have our equation, now we can answer part B and part C. Part B says find the temperature after half an hour. So we're looking for y when t is equal to 0.5. So you want to find y when t is equal to 1/2 or 0.5. So you use the equation that we just have right here. I like to write y instead of f of t just because it's easier. And so in the place of t, you're just going to put in 1/2 and number crunch it. That's it. You just put it right in your calculator. And when you do that, see if you get, along with me, 76.6, somewhere around there, degrees Celsius approximately, 76.6. All right, so the temperature after half an hour is going to cool down from its beginning 100 degrees to 76.6 degrees. And then the last question says, how long will it take? So we want to find T for the coffee to cool down when y is equal to 50 degrees Celsius. Okay, so we use our equation that we found, and we let y be equal to our 50 degrees. So 50 equals the 20 plus the 80 e to the negative 0.693 times t. So we're looking for t this time. A common algebra flubub is that somebody would add the 20 and 80 together. Okay, we don't do that because that's 80 times e. So make sure you're using order of operations as you're doing your work. So first you would subtract your 20. And then divide by your 80. And then you're just going through all your same steps again, taking the natural log of both sides and finding t. And then divide both sides to get your t. Okay. And it's going to take it 1.415 hours for your cup of coffee to cool down to 50 degrees. So in each of these problems, you see, once you get the original formula, you're doing the same thing every time, right, to solve it. You have to pay attention to, am I plugging into Y? Am I plugging into T? If I'm plugging into T, make sure I use the right year. Make sure I use the right time. Okay, those basic kinds of ideas. Does anybody have any questions about exponential decay or growth? All right. I'm going to spend just a few minutes leading you into where we're going in Chapter 9. At this point, I'm going to start opening up everything that's left for the semester. So if you want to work ahead, you can. Please pay attention to due dates. I think all your homework is due by the 6th, December 6th. And then by the 8th, we'll start having reviews and testing because we have one more test to go. That last test will be an online test, so that kind of helps you get a feel for, I'm getting ready to take the exam, and there's, you know, you're just going to sit down and you're going to take it. You're going to have one chance to take it. You're going to have a certain amount of time to take it in. And so it just kind of helps you get into that environment of doing that. Leading up to where we're going to go in 9.1, I want to make sure that you have your calculator next time. This time I'm going to show you a problem and I'm going to do it by hand. And then next time we're going to do the same problem, but we're going to use our calculator. And having your calculator is going to be a wonderful thing. Okay? And so I'm going to start off just by showing you by hand, and I'm going to use the smart screen to do that. What we're doing are things that you've done, I know, before now, which is just solving a system of equations. And that means, like, if you have 2 unknowns, you need 2 equations. If you have 3 unknowns, you need 3 equations. So probably 2 unknowns, 2 equations, you can whip it out pretty quickly if you're doing it by hand. But if you start getting 3 equations and 3 unknowns and you have to do that by hand, it gets very tedious. If you make a mistake somewhere, the whole thing's wrong. And so it is very nice to be able to use your calculator. But here, in solving a system of equations, the idea is this. Most everything we deal with are going to be lines. So if I have 2 lines and they intersect at one point, what this means is the coordinates of that point, I'm just going to call it 2, 5, for example. If I've graphed them and that's the point where they graph. What that means is that, remember this value 2 represents an x value. This value y represents a y value. That means if I were to take that 2 and that 5 and plug it into the equations for both of those lines, it would satisfy both of those equations. Okay? So when you solve a system, really what you're finding is you're finding the point where those 2 lines or 3 lines intersect. Okay? So that's what you're doing graphically. So algebraically, let's look at this one. We have 3x plus 2y equals 11. And minus x plus y equals 3. So this is a system. 2 equations, 2 unknowns. I want to know what's the solution. That means tell me the x and y that satisfy both of those equations. That means if I were to graph it, that's the point where those 2 lines intersect. So some of you even know how to graph these on your graphing calculator and find the point of intersection. That's what we're doing. All right? 2 basic methods for solving this. You can either use substitution or the elimination method. And I'll show you both relatively quickly. This is the substitution method. The substitution method is what it means. I'm going to substitute. I'm going to put one function inside the other. So, you know, for this one, I could rewrite this one as y is equal to 3 plus x, right? Just by rearranging it. And then what you would do is you would take and put that value substituted inside the other equation. So then I would have 3x plus 2 times this y, which is 3 plus x, equals 11. You see what I did? In the place of the y, I put in another way to write it. Now look at what I've got. I have one equation with one unknown. So this would just easily be solved. Combining like terms. Subtract 6, 7, 8, 9, 10, 11. And x is going to be 1. And now that I know that x is 1, I can plug it right in there and tell you what y is equal to. Y is equal to 3 plus x, so y is equal to 3 plus 1, so y is equal to 4. So my answer is 1, 4. They tell you to give your answer as a coordinate because remember what it represents. If I graph it, it's the point where those two lines intersect. You can always check yourself. Remember the 1 represents your x, the y represents your 4. So if I were to plug a 1 in for x and a 4 in for y, it would make each of those a true statement. Okay? So that would be a way to check it. It has to satisfy both of those equations. So that's the first method that you've probably seen before, the substitution method. And then the second method of solving the same problem is called the elimination method. And this is where you make sure that all of your x's are lined up and all of your y's are lined up and anything that doesn't have an x or y is all lined up on the other side. And the idea is that I want to add those two equations together to produce one equation. But to do that, I need, if I only want one equation, I can only have one unknown. So I want to add them together so that either my x's cancel out or my y's cancel out. So what I'm going to do to this second equation right here, I'm just going to make a note. I'm going to multiply. Remember, if you have an equation, if I multiply the left-hand side and the right-hand side by the same number, I still have a valid equation. So I'm going to multiply both sides. I'm going to say times 3. I'm going to multiply both sides by a 3. So that's going to give me a negative 3x plus 3y equals 9. See how I multiplied each side by 3? I'm not going to do anything to the top equation because I have set it up so that now when I add them together, notice that my x's will cancel out. And so I'm going to end up with 5y equals 20. And look, if I divide both sides by 5, I get y is equal to 4, which is the same thing I got earlier, right? I found out that y was equal to 4 earlier. So I know that y is equal to 4, and then you just take that and you substitute it into either one of your original equations. Do the one that's simpler. And so I would put it into the second equation because it's a little simpler. And then that's going to be minus x is equal to, subtract 4 is a negative 1, so x is equal to 1. So notice that I get the same answer, either method that I use. And you've probably, I think, done that kind of work before now. Now, what we're going to learn to do as we're coming in and approaching next time is instead of writing this original problem, I'm going to look at all the coefficients. So like here I have a 3, a 2, and then I've got an 11, I've got a -1, a 1, and a 3. And from that, I'm going to create a matrice or a matrix. And we're going to talk about matrices next time. But what I'm going to do is I'm only going to write the numbers down. Basically, it's a shorthand way so I don't have to write all my X's. But I have to have all my X's lined up, all my Y's lined up, and all my numbers lined up, okay? If you don't have it in that order, then it's not going to work for you. And what we're going to learn how to do next time is I'm going to go to matrix, show you how to put that in your calculator, and your calculator is going to do something called row echelon form, and it's going to reduce this problem down to 1, 0, 1, and 0, 1, 4. This is what your calculator screen is going to look like. And from that, you're going to say, oh, this was my X column. This is the one that talks about my X's, and here's my answer. This is my Y column. Here's the one that has something in the Y column, and here's my answer. Notice that it's a 1 and a 4. So that's what we're going to learn how to do next time. All right, make sure you keep up with your homework and let me know if you have any questions about anything. Okay? See you next time.